So today we are going to be looking at the ECT and IAT sensors on this 2011 Chevy Equinox. So let's go ahead and get started. So the location of the intake air temperature sensor is right here. It's built into the MAF sensor, and on the diagram they found on all data, you can see that the air temperature sensor is built in with a mass airflow intake sensor, and it is also a single. The ECT sensor is going to be located on the back side of the engine. If you follow the silver line all the way down, it's this sensor right here. There we go.
Do the back program and all that shit.
Yeah, you record. I've now unplugged the engine coolant temperature sensor. So if everything is functioning properly, the fan should stay on after I shut the vehicle off. So as you can see, the engine temperature is cold. So the fans should not kick on. Well, if the sensor was plugged in, the fans should not kick on if all is working properly. So I'm about to shut the vehicle off. And if everything is working correctly in the system, the fans should still be running, which they are. I will now attempt to plug the sensor back in, and the fan should shut off. And everything is working properly. So now we're going to attempt to back probe the ECT sensor. So you can go ahead and
you want to come take a look. Got the ECT sensor here, back probe them both here. Now what we're going to do is set our voltmeter on ohms and then jump across the sensor, so we're only testing resistance of the sensor and nothing else. It's going to fluctuate a little bit, but then the highest reading that we will see is around 4,000 ohms that it'll jump up to, but right now it's settling out to about 2,500 on average.
So now we're going to attempt to back probe just like we did the ECT, but now with the intake air temperature sensor. We're going to get started with that.
We're going to come over here. We got back probe for the tan and blue wires, which is the intake air temperature sensor. Like we did for the ECT, turn it to ohms and then measure resistance. Lady there. What we're getting is about the same for the ECT, around 2,500 ohms on average. We are comparing the intake temp and the coolant temp. This car is a little warm right now, but the intake temp is 106 and the coolant temp is 147.
So now we've started the vehicle, and then we're going to wait until it gets up to operating temperature, and then we'll determine when the fans turn on and when the thermostat opens. So we'll go ahead and do that.
If you come take a look, right now we're at 176, but in this car the thermostat will open at 172. If we go to in the engine bay, you can feel the upper radiator hose right here, and if you just feel it with your hand, you can feel there's coolant moving through it.
The fans have been researched to come on at 205, so we're just waiting for that. 205, the fans should kick on. There they are. $205 degrees, and they should go till it's about 185 or so, and they'll shut off. So today we are identifying throttle position, sensor functions, and features on this 2006 Suzuki Verona here.
So as you can see in the back, we got a throttle position sensor right here. I got the connector disconnected, all of our colors and wires in the back, and it is throttle by wire. If you come over here and look at the diagram on all data, all these colors right here, those will line up with the sensor that was just showed.
We are now just gonna test the red wire here to confirm that that is the ground. So right now we are attempting to test the blue and white wire there on the TPS sensor. Key on, engine off with the sensor plugged in. 3.14 is the volts that we're getting there. Now we're gonna go ahead and test the blue wire here on the TPS sensor because they should have varying voltages regardless of having the same function. Key on, engine off once again.
We got 12 volts at the blue.
Now we have 12 volts. So like we were talking about with that variance, one's going to start at a higher voltage, one's going to start at a lower voltage there. So it looks like that blue wire starts with the higher side. So now we're testing the green. Getting a reading of 4.1 steady. And then as you input the throttle, the voltage goes lower. The more throttle you give it, so it starts high and goes low. Now we will be attempting to perform a sweep test, and we will make a graph recording all the results as accurately as possible. So now we're performing the sweep test. This is key on, engine off at idle. I'm going to try to go in 10% increments here. So this is idle. This is just starting to open. A little bit more. This is probably about halfway. A little bit more. This is probably 90%. And then wide open. So as you can see, it started high voltage and went down slowly. So I'll bring it back down. This is about halfway. And then at idle. Here are the results that were found from that sweep test that we did. Unfortunately, I wasn't completely accurate with the 10% increments here. Made it as close as I could. But starting at idle, it's around 4.1 volts, and then 10%, 3.6, 25.30, and so on. All the way to 100%, it was at about half a volt, 0.6 volts, which is on par to the information that we saw on all data earlier. So now we are doing the resistance test for ohms here. Just straight in the connector, we're not back probing this one. And then we're getting about 4.5 ohms. Okay, so now we are back probing the signal circuit and performing a sweep test with the picoscope here. So we're gonna go ahead and, to the best that we can, do increments of the throttle. So right now it's all the way closed, and it's about 4.1 volts here. And then we'll go ahead and move the throttle slowly. So as you can see, as it opens, the voltage slowly starts going down. And as you can see it going down, and then this is wide open throttle right here. And then that is going to be roughly at about 0.7 volts or so. And then obviously with the throttle all the way closed, it is going to be just above 4.
So with this first one, we've got DTC P0122, throttle position sensor low input. That is saying that if the TPS voltage is less than 0.3, it's gonna throw a mil. And then if you scroll up, we can go to the next one. And this one is for high input on the TPS. And if the TPS voltage is greater than 4.9, it's gonna throw a mil. And then this next one, which is the last one, P0121, it's a rationality check. So it's basically conditions for setting the diagnostic trouble code. Engine speed is between 1,000 and 3,500. Relative engine load is between 0.3 and 0.7. Engine load is stable. Vehicle is operated in closed loop condition. No relevant DTCs are set, and the TPS signal indicates a value other than expected.
So we ran some tests on that Suzuki over there, that tan one, which is drive-by-wire, and now we need to run a couple more tests on electronic throttle. So here we have this Chrysler SRT8. So we'll go ahead and get the potentiometer hooked up, picoscope hooked up, sorry, and run some tests on that. So as you can see here, picoscope reading we have here, the lowest peak that we got, the lowest of the low that we got here was about 0.7. And then the highest, which is this tiny little peak up here, ended up about being 1.6. But if you don't count that tiny peak, it's going to be still about 1.6. So those are the readings that we got there for back probing, but now it's on the electronic throttle instead of drive-by-wire. Nice.